In this demonstration of PLM 360, we'll run through a typical day-to-day scenario within a manufacturing organisation. In this case, an industrial machinery manufacturer known as Unique Specialist Products, or USP. USP produce a range of process equipment. In our scenario, there's a problem on site with one of our products, which we need to investigate and try to rectify. So let's start by logging into PLM 360 as USP's service manager, Mike Mendit. Now it's worth pointing out here that no software has been installed on my laptop. Mike has accessed PLM 360 with just a web browser using his account login details, just as you would log into Facebook or Google Mail. Now security is a key priority with PLM 360. Protecting our customers' IP is critical. We use 256-bit encryption, which is a very high level. Even a lot of banks still only use 128-bit encryption. So your valuable data is secured. We also employ data centers who work to the full international security standards. Even Autodesk can't access your data without your permission. Now access to PLM 360 is contextual. The tools and data available to you depend on who you are. Mike is the service manager, so needs access to information such as engineering changes, customer details, and service data. He doesn't need to see unrelated information such as sales and marketing data or manufacturing process details, so that is all hidden from him. He can easily find what he needs to do his job without being swamped with other irrelevant information. PLM is all about giving the right information to the right people, and analytical reporting is a key part of this. Each user can set up their own dashboard of charts which report on data within PLM 360. These reports are all in real time, so keep each person informed on what's important to them, whether they represent a specific department or a part of the executive team. In this case, Mike needs to be kept informed on the number of recent service requests by customer, the number of recent field failure requests by severity, and the different components that have recently failed in some way. And it's easy to change the look and the feel of each chart. You might want to capture it and send it to a colleague or paste it into a document, for example. PLM 360 allows you to change how you visualize the chart to give you the flexibility on how you do that. So for example, we can change our values from percentage to numeric. We can rotate the position of our pie chart. We can get a 2D view of it rather than 3D. And even take one of the sections and bring it out to highlight it in more detail. Now if we take a closer look at another of these charts, highlighting recently failed component parts, we can see that there are two items which are proving to be problematic, which we can investigate in more detail later. Now, just like with a web browser, in PLM 360 you can create bookmarks or dashboard links to items such as a project you're working on or the top level assembly of a product you're developing, or just to an individual component part. Here, Mike has previously created several bookmarks, links to a recent service request and a field failure request, as well as links to the two problematic components which were highlighted in our chart. All Mike has to do is click on that link and he will immediately be taken to the record for that item, in this case a ball valve which has been failing in the field. He can investigate that item further to get more information about it, see what it looks like, which products it's used on, who supplies it, and so on, all in one single place. PLM 360 highlights to each person the tasks they're currently involved with. Every time a new task is created, such as when a process workflow is moved on to the next step, or someone else creates a task for that person in the project plan, that item is added to this list. There's also the option for that person to be emailed at that point, so they'll immediately be aware that they have a task to do, even if they're not logged into PLM 360. And we can see that Mike has a number of tasks outstanding. These include several service requests, the items with the SR prefix, and also a field failure request, which has just been submitted by one of his service engineers, Ian Infield. He's also received an automated email from the system to inform him of this, so he needs to find out more about this particular problem. Mike just needs to select this item to look at the field failure request details. We can see which machine in the field has the issue, who the customer is, and further details of the problem. In this case, Ian, our service engineer, has identified a pneumatic cylinder which is continually failing, causing a critical severity problem. Ian has used PLM 360 on site, using his mobile device, to enter this information during his site visit. Mike can therefore get a good understanding of the issue even before his service engineer has left site. Mike can also see which assembly the issue relates to and which cylinder is failing. We can get further details of the cylinder very easily, including the type and specifications and the various references we have to it in our internal systems. In PLM 360, documentation can be attached to any item, providing easy access for people to information associated to the task in hand or the component being accessed. This reduces the time wasted looking for that information elsewhere and reduces the risk of costly errors due to the wrong information being referenced. Here, Mike can see the technical details of the cylinder provided by the manufacturer. Mike can also see who supplied this cylinder and its cost, and can even gain further information on that supplier, such as whether they're approved, the main contact details, and even an embedded interactive map showing us their location. So by now you should be getting a good idea of how information is related in PLM 360 and how, with just the click of a mouse button, you can easily and quickly access all of the data related to a particular item, such as a component or, in this case, a field failure. So moving on, according to our internal processes, Mike needs to kick off a corrective and preventative action or CAPA process in an attempt to get the problem investigated by the design team and to ultimately have it resolved. He can easily create a new process in PLM 360. Now, to save time, here's one already created and populated, and we can see that Mike has entered information such as the supplier of the cylinder, the team who'll need to investigate the issue and approve any corrective actions, details of the problem and possible causes, and a link to the relevant field failure request. He has also linked the assembly in question and the problematic pneumatic cylinder. Now, any processes within an organization can be mapped and managed in PLM 360 by the workflow capability. Now, this can be something at a high level, such as a complete new product introduction process, or the process involved in engineering change or release, or smaller departmental processes, such as the creation of a piece of quality documentation. These process workflows are easy to set up and modify should the business undergo the need for change in any area. Process workflows can be made as flexible or as tight as an organization requires, with different individuals involved at each stage. They ensure that company processes are made widely visible so that people can better understand them and that all of the stakeholders in a particular task or project know the current status of that task or project. Now we can see that Mike has moved the process to the define phase, as this is highlighted in green. He's actually just completed this phase by entering the problem definition information we saw a moment ago. He can now move the process on to the next phase by selecting the green arrow to Submit for Measurement. The process is now at the measurement phase. For any process, we always know what stage it's currently at. Any stakeholders in a product can see at a glance how complete it is in real time by looking at the process workflow. They can also be informed via email if there's a bottleneck in a particular process, if it's been at a particular stage for too long, for example. This helps to make sure processes move forward and reduces the risk of delays. Now we can see that the next action in this process is to submit for analysis. However, this is not appearing green to Mike because he doesn't have the authority to do so. If Mike selects the current state box, he's informed of who can sign that phase off. In this case, only the team defined as having authority to process the rest of the kappa can do this. In PLM 360, we can restrict process sign-off to only those who are authorized to do so, and even dictate the need for a digital signature via re-entering of a password if we need an extra level of security. So we're now going to log in to PLM 360 as David Design, the Product Development Manager within the design team. David has accessed PLM 360 in the same way as Mike and reaches the same common single PLM environment as everyone else within the organization. But he gets his unique view of that environment. You'll see that the apps or workspaces available to David are different to those available to Mike previously. Again, David can easily find what he needs to do his job without any unnecessary noise. And also, David's analytics dashboard is different to Mike's. He sees information relevant to him, such as the status of recent change orders, or the proportions of parts and assemblies in different lifecycle states. Charts such as these are easy to create and can be private or shared across the company. Again, this is an example of giving the right information to the right people in a timely manner. Now if we look at David's outstanding work or to-do list, we can see the same kappa item created by Mike. Because David is one of those authorized to sign the next step off, he has been informed that this is a task he's responsible for. And he would have also received an email to ensure that he was informed immediately of this task. David can select this item and immediately be informed of what the problem is, what needs to be done, and the affected assembly and problematic cylinder. For example, he can see the full bill of materials for the head assembly. The full lifecycle control capabilities in PLM 360 means he knows he's accessing the correct version of that assembly. If he needs to access a previous version, he can easily do that. For example, if the assembly failing on site is a production revision A version, he can access that bill of materials. Alternatively, if it's the current production version, he knows that's revision C, so he can access that instead. If he knows the date when the head in question was assembled by the manufacturing team, he can also set the bill of materials to that date and view its configuration from the time it was built. This ability to trace back a bill of materials from a certain date enables accurate traceability of the evolution of a product. So, what other information can David obtain from the bill of materials? Well, he can see each component and subassembly and can select any of those items to study them in more detail. For example, if he wants to know more about the upper bushing assembly, he can do that easily, having quick access to detailed information about it and, for example, its own bill of materials. For each item in this assembly, he can see a part number and its revision in the assembly. Alternative reference numbers, in this case each item's entry in the company's ERP and CRM systems, quantities and weight information for each one. The latter is rolled up to give an overall weight for the assembly of just under 4.4 kilograms. In PLM 360, we can configure bills of materials to roll up any values we might need. Weight, as shown here, is a common example. Cost would be another. This capability saves time and effort otherwise spent manually calculating these totals, and remains up to date when any changes occur. The bill of materials also informs us if any item is the subject of a current engineering change. The green pending change icon next to the bore seal, item 1.6, tells us that this is just such an item. Moving our mouse to it, we can see which change order it is associated with, and we can click on this to get further information. So having this fact plainly highlighted to us means we can take this into account in any decisions we make. If the manufacturing team were about to build an assembly, for example, seeing this on the bill of materials may prompt them to ask questions rather than blindly building a product with obsolete or faulty parts. This reduces the risk of potentially costly and time-consuming downstream errors. We can also configure different views of a bill of materials, giving individuals the information most relevant to them. David is looking at the engineering view currently, but if we were to select our predefined purchasing view, we would see additional information, such as supplier details and their equivalent part numbers, and also costs for each component with a total roll-up for the whole assembly. Being able to configure contextual bills of materials in this way helps to give individuals the exact information they need without any unnecessary data. Now, because PLM 360 is a true web-based cloud product, we can confidently navigate via our web browser, as we would when looking at any other website. So, to go back to our main head assembly, we can just use our browser back icon as many times as we need to. So let's move forward a little. David, the product development manager, has determined, with the help of the information in PLM 360, that a larger pneumatic cylinder is needed. The current cylinder has a 200mm bore size and needs to be replaced by one with a 250mm bore size. The stroke has to be the same, 100mm, and he wants to use the same specification of cylinder, known as a Type CS1. So he can filter the master list of components and assemblies in PLM 360 down to just those with a CS1 prefix, which gives him a list of all of the CS1 type cylinders available. We can see that there are some 250mm bore cylinders, but they are the wrong stroke length. The only one with a 250mm bore and a 100mm stroke, unfortunately, doesn't have the correct mounting type. We therefore need to source a new cylinder and make any design changes necessary to accommodate the change. We also need to move the kappa process forward to document our solution to the problem. So moving forward a little again, here is the completed kappa record finished by David, outlining the causes of the issue and what will need to be done to rectify it. This is a record of the investigations of this problem, which will remain available to anyone who needs access to it in the future. We can also see the workflow, which is now at the end of the process, ensuring all stakeholders are aware that the kappa is complete. Every step of this kappa process has been recorded. We can see who signed each step off, in this case Mike and David, when it was signed off, and any comments made at the time. Traceability is a key requirement for many organisations for their own as well as legislative compliance, and this is a key element to PLM 360. This is a great example. We can easily trace the details of this kappa record and its progress from start to finish, if we need to for auditing purposes, for example. In fact, PLM 360 traces every activity carried out, such as each item added or changed, each task completed, and each workflow stage signed off. So here we can also use the knowledge captured in the Kappa documentation to help others learn about this issue and improve the quality of future products. In PLM 360 we can add the element of time to any process workflow through the use of milestones. We can apply a target date to some or all of the stages in the workflow. These milestones can be added manually or automatically created when the process is started. We can see that milestones have been applied to this Kappa process, and now the process is complete, the traffic light indicators give us a fuller picture of how efficient the process was. The early stages were completed late, hence the red colour, but then we managed to claw back time as subsequent stages are showing amber, outlining that this stage was completed close to its due date, and then green, telling us those latter stages were completed on time. Using milestones, any stakeholder in a process can track its progress, being informed if it looks like any stage is going to be late, so that we can do something about it in good time. They also indicate to us how efficient a completed process was, and at which point any delays occurred, so that we can learn from this in an attempt to speed up the whole process. Now if we look at the page which gives us details of the Kappa, we can see at the bottom that a change request has automatically been created for us as a result of the Kappa being finalized. In USP, the engineering change process dictates that once a Kappa is complete, if a change is required as a result, a change request must be raised, and then a change order again if required. PLM 360 has done this for us automatically, and we just need to select the link to access the change request. In this change request record, we see that some of the information from the Kappa, such as the description of the problem and the reason for the change, have been populated automatically, saving us time and effort. A link has also been created automatically to the Kappa, closing the loop in terms of traceability. In addition to this, we've added the names of the Change Control Board approvers, which will determine who can sign off certain workflow stages. Information on projected costs also needs to be added. It will be down to our purchasing team to determine the cost of the new cylinder, but up to David to explore the cost implications from an engineering point of view. Now the main thing to consider is the cylinder mounting plate. This will need to be modified to accommodate the new larger bore cylinder. David uses the search capability to find the mounting plate, using specific keywords to locate it. David can easily check which assemblies use this plate. PLM 360 gives us this information so that we can assess the impact of any change we make. In this case, we can see the plate is used on a couple of other assemblies, so we know we'll have to create a new part rather than revise and up-issue this one. Knowing where else a subassembly or component is used is an invaluable tool when considering product changes to help understand the impact and potential costs. Using this knowledge, David is able to better estimate the engineering costs of the change, and the manufacturing team can add their estimates on costs affecting production. So, once the purchasing team have also liaised with their supplier regarding the costs of the larger cylinder, the full cost impact of the change can be determined and recorded. Here we see the completed change request showing those details. In the interests of time, let's say that the change request workflow has also been fully signed off by those on the change control board, as defined earlier. You'll see that sign-off was required by both of those approvers, David and Chris. When defining who can sign a workflow process task off in PLM 360, we have full flexibility. We can specify whether one of a group of people can do this or all of a pre-specified group of approvers. If we take a look at the details page for this change request, just like with the kappa earlier, completing this process has spawned a new one automatically. In this case, a change order, which we can access as before by clicking on the link provided. This automatic spawning of new processes, depending upon the outcome of the current one, is a great mechanism for ensuring the smooth flow of those processes right through to their conclusion. Stakeholders in those processes can be automatically informed when tasks are signed off or when they have a new task to action, and everyone can visibly see the current state of the chain of processes at any time. And this all helps to dramatically reduce process bottlenecks and ultimately decreases lead times. Also, these processes will all be traceable, so at any point in the future, anyone can follow the whole story of how, why, and when this change came about. To be able to do this easily is critical to meeting many different compliance requirements. So to end the demonstration, we jump forward to a point in the future when the engineering change is complete and the new machine with the upgraded pneumatic cylinder has been finalized. We're going to log in to PLM 360 as Frank Floggett from the USP sales team. Frank has had a sales inquiry related to the revised product and wants to familiarize himself with the changes which have been made. He has an item in his dashboard links section which takes him straight to the new assembly. We can use the BOM compare function to look at the differences between the bills of materials structure of the new assembly with the original and visibly see what's changed. So, for example, we can see the cylinder has been replaced. And we're also informed of how that impacts on cost. We can also see the same information for the revised cylinder mounting plate. Also, if we look at item 1.1, this is the bushing subassembly David looked at earlier. This has also been revised in this new head, and again we can see the impact of this on its overall cost. There's actually not much difference in this case. However, if we look at a different view of the bill of materials, showing weights, the impact here is greater, and the new subassembly is significantly heavier than the previous one. Using this BOM compare function, we can easily see, via very visual means, the difference between two assemblies, or even two versions of the same assembly, helping us to very quickly understand the impact any changes have had. As well as the ability to attach documentation to an item, as we saw earlier, we can also attach 2D and 3D CAD and visualization files. In this case, David has the complete new head available to him, which he can dynamically manipulate with the embedded viewer in PLM 360. He could also add notes for others to see if he needs to. Using this capability, we can get a much better understanding of what products, assemblies and components look like, helping those such as manufacturing engineers, site engineers and the purchasing department to identify items without the need for potentially expensive design software. So that concludes our demonstration, where we've seen the life cycle of an engineering change and how PLM 360 enables us to manage that change, to make the process faster and more effective, to give all stakeholders better visibility of the change and its impact, and to ensure full future traceability. There's so much more to PLM 360 I could show you, but just in this short demonstration you can certainly get a taste for how PLM 360 can bring a host of benefits to the whole organisation, from sales through to service teams, enabling everyone involved in the product development process to be better informed and to collaborate more effectively, leading to the faster creation of an innovative and high quality new product.